Okay, so here we'll be looking at resultant moments. Last year in year 12, we looked at resultant forces, where if I had a force of magnitude 10 to the right and a force of magnitude 2 to the left, the overall effect of those two forces was magnitude 8 to the right. We're going to do a similar thing with moments. If you remember at the end of the last video, we had these two moments applied to the point P. Well, which one or which direction is winning out over the two? One of them was 10 Newton meters clockwise, and the other was 12.257 Newton meters anti-clockwise. The overall movement is going to be anti-clockwise, and taking the clockwise direction as positive, the anti-clockwise direction as negative, we can actually calculate how much anti-clockwise moment we have. Negative 2.257, which is 2.257 anti-clockwise. Okay, so now let's just have a look at an example you may have in front of you. To find the resultant moment, we'll start with the clockwise moments, since they'll be the positives. And the only clockwise moment here is the 5 newtons. So 3 times 5. The other two forces will produce anti-clockwise moments, so I'll subtract those. So 1 times the 4 and 1 times the 3. So just a little bit of arithmetic here gives us an answer of 8 Newton meters. So that's 8 Newton meters clockwise. We had a positive value, so that means we're moving clockwise. Okay, so let's go in for another one. This we can see has some diagonal forces, so we are going to need to find the perpendicular components for us to be able to work with. So the clockwise forces we'll start with again, and I know that the 5 Newton force is clockwise, so the perpendicular distance, 4 sine 80, multiplied by the force of 5. Okay, the other two forces are going to be anti-clockwise. We've got an easy one here, 3 times 6, and we've got the perpendicular on the 4 Newton force, which will give us 3 sine 40 multiplied by the force. All right, resolving with this, just punch it into the calculator. I'll get negative 6.02. Negative means we're going anti-clockwise. 6.02 anti-clockwise. And in this example, we once again have diagonal forces. We're going to resolve around the point P. So let's start with the clockwise force, which is going to be the 7 newtons. So 8 sine 25 multiplied by the 7, and we'll subtract 8 sine 35 multiplied by the 4. Leaves us with 5.31. Positive number means we're going clockwise. 5.31 Newton meters clockwise. So let's have a look at what happens if we had the resultant force, but we didn't actually have one of the distances or one of the forces in the original diagram. So just a quick diagram for you. Let's go ahead and do what we would do usually. There's obviously going to be some unknowns. So this unknown distance multiplied by 5, plus the other clockwise force, which is 2 times 4, and subtract the anti-clockwise force. And since I know the resultant is negative 3, because it was anti-clockwise, I can go ahead and simplify and rearrange to get an expression for that unknown distance that I've called d. So in this case, d equals 9 over 5. 1.8 meters. So it's the exact same technique. We get expressions for each of the moments. I do clockwise first, then I subtract the anti-clockwise, and that should equal your resultant.